What stinks is I already did this video once, then I realized that I didn't like the homework assignment, so I modified the homework assignment. Now I get to do something again. So, this is the homework for 7-6. And the first one it's highlighted and bolded is number 3. Number 3 is actually straight out of your notes. The property here is log base b of some argument x equal to log base b some argument y, x is y. So x squared minus 4x must be 5. X squared minus 4x minus 5 is 0 because we solve quadratics by setting equal to 0. Because hopefully we can factor, and we can. Actually, it's not straight out of your notes. It's just very similar to one. Anyways, we get x is 5 or x is negative 1. And nothing can screw this one up. And if you plug in a negative 1, this is still going to be 5. If you plug in a 5, that's 25 minus 20. They're both real. What's up next? Number 6. Solve by condensing and then exponentiating. So I know that a log a plus a log b is a log containing the product of a and b. So that's what I do. A log base 4 of a negative x times an x plus 10 is now equal to 2. And remember, log is bay, right? Log is bay. So here's my base, here's my exponent, and here's my answer. 4 squared is, I'm going to go ahead and distribute, negative x squared minus 10x. I'm going to shift everything left. I'm also going to turn this into a 16. Oops, positive 16. X squared plus 10x. So I just shifted everything left. There are factors of 16 that add to 10. They are 8 and 2. So my x values are negative 8 and x is negative 2. And then I'm going to make sure they work. If I plug in a negative, that's positive. If I plug in a negative, that's positive. If I plug in a negative, it's positive there and it's positive there. So they're both real. 8 is highlighted as well. It's the same thing. Just condense them. A singular log base 5 that contains the product of x plus 4 and x plus 1 is now 2. So when I do my conversion, 5 to the second is equal to, I'm going to go ahead and FOIL, x squared plus, looks like 5x plus 4. I'm going to shift this guy over here and make him negative, because I want to be set equal to a 0. 0 is x squared plus 5x, and 4 minus 25 is negative 21. Now factors of 21 are going to be 7 and 3. Nothing's going to add to a 5, so I'm going to have to go off and I'm going to have to do the quadratic formula. Opposite b plus or minus square root of a b squared minus a 4 times a times c, all sitting pretty over twice a. What's in my radical? And my radical is a non-real number. It looks like to me. No, there's a real number in there. I have 5 minus 4. Sorry, I have 5 squared minus 4 times 1 times a negative 21. There's a real number in there, 109. All over 2. Now, one of these answers is probably not real. Negative 5 plus a root of 109 divided by 2 is 2.72. And that's not going to be a problem for either one of these things. So I know that the real answer here is negative 5 plus the root of 109 all over 2. And I got a hunch, and I'm going to check it, but the negative one is going to be extraneous. Negative 5 minus root 109, sitting pretty over 2, is a negative 7. And if I take a negative 7 and put it here, and negative 7 put it there, I'm trying to take the logarithm of a negative. So the extraneous is that conjugate. The bell rang, so I gotta let some kids in, but I got started on it. That's the big deal. pause this.
I'm just looking at prices per unit per lead. So whether or not I should buy some pigs.
You're going to get into livestock?
How are you?
Oh, cool.
Small farm. We have turkeys, goats, chickens, pheasants, some sheep.
Sounds like a hippie commune. Kinda?
Pepitas worse than that.
Sorry, kids, I've been talking to Zeke here. Suppose an investment pays 25% on a yearly basis. If you invest 10 grand for a month, what will it be worth? What was the effective monthly interest rate? So we're paying on a yearly basis. I get to use the formula for exponential growth. Normally, when you use this thing, time would be something like a whole year or whatever. This is on a yearly basis. The rate of 0.25 is on a yearly basis. I need to change this into a monthly equation by putting a /12 there, because now it will accept months. So I am going to invest for 1 month. It's going to be 10 grand. 1 plus 0.25 is 1.25 to the 1/12th power. So let's see what this becomes. You take your 10,000, 1.25 rooftop to the 1/12th power, and after a month it becomes $10,187.69. So we're going to figure out how much money we gained, which is easy. This take away 10,000. So we gained in 1 month $187.69, and I want to know the effective monthly interest rate. Well, I'm just going to divide it by what I started with, 10,000. That'll give me my effective interest rate. So you take your 187.69265. Sorry, I didn't even think about what I gained. This is what I have. I had a brain fart. I'm going to take that and divide it by what I started with, 10,000. There's what happened here. So I grew by 101.88%, which means that the effective rate was 1.88. That was the effective rate, 1.88%. Now what else we got here? We got 15 being bolded. 15 is an exponential equation, and there's no way to turn a base of 2 into a base of 10. So we're going to do a little technique here that I probably have not taught yet, but I will teach the next day of instruction. The technique is called ln both sides. So we take the natural log of the left, and we take the natural log of the right. And then we think about the property log a to the r. We put the r out front. There's 2 terms in these r's, so when I move them out front, I got a wrap. Then I invoke the distributive property, and these get kind of fugly looking. 3x natural log of 10 minus 8 natural logs of 10 is 5 natural logs of 2 minus x natural logs of 2. And just that ugliness is what really scares the crap out of kids. These things are ugly. I'm going to take everything with an x and move it to the left, and I'm going to take everything that's not an x and move it to the right. So on the left, I'm going to have 3x natural log of 10 plus x natural log of 2. On the right, I'm going to have 5 natural log of 2 plus 8 natural logs of 10. Then I'm going to do the first commandment math, which is to factor. I can pull an x from both these pieces. If I pull an x from 3x ln 10, there's 3 natural logs of 10. If I pull it from x natural logs of 2, there's a natural log of 2. and the right-hand side stays the same. And I'm already wishing I would have written smaller. This is all attached to x through multiplication, so I do a little bit of division. And that is my answer. Kind of an ugly looking answer. 18, not near as hard as 15. 18, the common base would be a 6. 36 is a 6 squared. There's already a 5x plus 2 up top. Turn a 1/6 into a 6th, just think about that understood 1 being moved up top. Becomes 6 to the negative first. Bases are the same, chunk them out the window. Distribute that 2, 10x plus 4. Distribute that negative 1 is x minus 11. X is on one side, numbers on the other. 9x is a negative 15. X is negative 15 ninths, which reduces down to negative 5/3. There's your answer to that one. 19 and 20, they're highlighted. 25 is a 5 squared. 1 1/25, this has probably been done in your notes somewhere, is a 5 to the negative third. Distribute 20x plus 16 is negative 12 plus 6x. They give me 14x equals negative 28. The x value is negative 2. Almost done. Got 20 and then 22 left to go. I'm going to leave that 3 as it is because 81 is a power of 3. It's 3 to the 4th. Exponents are now equal. Distribute. X is on one side, numbers on the other. If you add 12 to 3, you get a 15. If you take away if you add 7 to 48, you get a 55. Divide by 15. Both those by 5, you get 11/3. And 22, it says determine all zeros, real and imaginary, of that 4th degree polynomial. And it says look at the graph. That's how you start. Or you can do, maybe you remember that day in class where we spent a lot of time guessing zeros. I remember it. But anyways, you can just look at the graph. Zoom 6, the graph will tell you anything that's real. And there's a real answer here, and probably there's a real answer there. That one's pretty easy. That looks like a negative 2. That one is probably either a quarter or a third. So I'm going to put a 0 into y2. That way I can use the intersect feature. Second trace 5. Get close. Enter, enter, enter. Oh, it was a third. Don't be that kid who writes down like x is 0.333. You're never going to be good at math. No offense. You're not. Don't write things like that. 0.333 is a third. You know that. You knew that in like 5th grade, 6th grade when they were teaching that stuff. I learned that in Palmersville. So what can I do with these things? I can synthetically divide them out. Since this is literally x is negative 2, I don't change the sign. I don't see a need for placeholders. Then we follow that DMA acronym. Probably 80% of the juniors can do synthetic division now. I'll know when I grade here in a little bit. So I drop, then I multiply, and then I add. Then I multiply, then I add. Then I multiply and add, and I got a 0. Of course I got a 0. That was a factor. That was a 0. Now I'm going to do the third. And it doesn't matter which one of these you do first. I just was saving the fraction for last. A third of 3 is 1. Negative 1 and 1 makes 0. A third of 0 is 0. 27 and 0 is 27. Third of 27 is 9. 0. You have a remainder, a constant, an x, and x squared. So here is the resulting, the last actual factor of this reduced polynomial. It's 3x squared plus 27. And there's 2 zeros there. So set it equal to a 0. It's an easy one to do. Subtract 27, divide by 3, Counteract squaring by square rooting. Remember you like pandas. Plus or minus 3i. So there are the 4 zeros of that polynomial. And that does it for your 7-6 assignment.